Hello everyone. Today we are looking at section 10.1, which is developing formulas for triangles and quadrilaterals. So what we are looking at today is finding the area of triangles and several different quadrilaterals. We're going to look at parallelograms, trapezoids, rhombuses, and kites. Okay, so the first thing that we're going to look at is the different area formulas. My formula for the area of a parallelogram is area is base times height. Now you have probably seen this previously when we were doing areas of rectangles and whatnot. As you were kind of younger in earlier grades, you did length times width for rectangles. Well, now we're using base times height for all parallelograms, which does include rectangles. Okay, hopefully our triangle formula you have seen before. Area is 1/2 base times height. And then our trapezoid formula is area is 1/2 times base 1 plus base 2 times height. Or we can say base 1 plus base 2 times height divided by 2. And I will typically, you will see me write my h in front, but I will use this style of formula. I just feel like it takes up a little less room on the page. And then our last formula that we're going to look at is for rhombuses and kites, is that our area is 1/2 the product of our diagonals. So D1 and D2 are the length of one diagonal and the length of the other diagonal. Please realize it doesn't matter which diagonal you call 1 and which diagonal that you call 2. One other thing to remember is that when we are looking at rhombuses, don't forget that a rhombus is a parallelogram, so it may be more beneficial for you to do base times height rather than 1/2 D1, D2. But it'll just kind of depend on what you're given and what you're looking at in each particular problem. Most of the time, you will use 1/2 diagonal 1 times diagonal 2. All right, so let's go ahead and start looking at some examples of this. So I want to find the area of the parallelogram. Okay, so we know that our parallelogram formula is going to be that our area is base times height. Well, if we notice here, remember that the height is always the perpendicular distance between the two bases. All right, so our dotted line out here is the height of our triangle. And notice that we do have a variable. So the first thing that we need to do is to figure out what this height actually is. So notice that this side of our parallelogram is a length of 5. This outside piece, outside of our parallelogram, is a length of 3. And we have a right triangle. So since I have a right triangle, I know 2 of the sides. I can use Pythagorean theorem to find the height. So that's my a squared plus b squared equals c squared. And remember that your hypotenuse, which in this case is 5, is always our c. So I'm going to set up h squared plus 3 squared is equal to 5 squared. Okay, so we're going to have h squared plus 9 is equal to 25. Subtract 9 from both sides, we're going to get that h squared is equal to 16. And when we square root both sides, we're going to get that our h is equal to 4. So the height is 4. Now this is where, again, knowing those Pythagorean triples kind of comes in handy, because if you do know the Pythagorean triples, then you can skip the formula. Remember that 3, 4, 5 triple is one of the most common ones that we're going to see. All right, so now that I know the height, I can use my area formula. So my area is base times height. Now, the base of my parallelogram is this distance right here. Okay, so my base is 6, not 9. Okay, I only want to include what's actually in the figure, and this 3 is the distance on the outside of the figure. So my base is 6, my height is 4. So now I can do 6 times 4, which is 24. Our unit is in inches, and when we are doing area, it is inches squared. Okay, so our unit for area is always squared. All right. If there are any questions on that, make sure you kind of note that down and write that down. Actually, that's really thick. Sorry, guys. Let's make it a little smaller here. There we go. Okay, So then we're going to look at the next one. I want to find the perimeter of the rectangle if I'm given the area. So I know this is a rectangle, so this is going to be my height, this is going to be my base, and I don't know what my base is, so that's what I need to do first. So when I am looking at my area formula, area is base times height. Well, I'm told that my area is 12x. So I'm going to plug that in for my area formula. My base is what I don't know. My height is 6. So I'm going to divide both sides by 6 to get 2x is equal to my base. All right. Now, we don't know what x is. It's just going to stay 2x. Now, for perimeter, remember that we add all the sides together. Okay? So I have two sides that are 2x because remember in your rectangle, it's still a parallelogram, and opposite sides are congruent. So I have two sides that are 2x, and I'm going to have two sides that are 6. So my perimeter is 2x plus 2x, which is 4x, and 6 plus 6, which is 12. Now, because I don't know x, I cannot combine this any further. And remember that perimeter's unit is in feet, okay, not feet squared. Area, your units are squared. Perimeter or any side lengths, your units are just your basic units without the square. All right, any questions on that? Please write that down on your notes now. And we're going to go ahead and move on to triangles. Okay, so we are told that a machinist is cutting out a triangular metal braces to support the legs of a picnic table. Each triangular brace is 3 inches high, so my height is 3, and 2.2 inches wide. So that's going to be basically the length of my base because that's where the widest part is going to be. So my base is 2.2 inches. So now I can write down my formula for a triangle. So my area formula for a triangle is 1/2 base times height. So I am going to have 1/2. My base is 2.2. And my height is 3. Now, half of 2.2 is 1.1. And when I multiply that by 3, I'm going to get 3.3. So my area is 3.3 inches squared. Okay. Again, for part B here, I want to find the area of the triangle. So I'm going to do my area is 1/2 base times height. Now, my base, if you look at the entire triangle, this whole side has a length of 16. Don't break it into two different triangles. You could do 1/2 6 times 7, and you could do 1/2 10 times 7, and then add them together, but just use the one big triangle. Whoop, didn't mean to make that mark. Okay, so use the one big triangle where you're just doing 1/2 base times height. So my base is 16, and my height is 7. So 1/2 of 16 is 8, and 8 times 7 is 56. So it is 56 inches squared. Again, if you have questions on triangles, and this is more just a review for triangles, again, this should be really nothing new for you. But if you do have questions, please go ahead and write them down on your notes now. And we are going to go ahead and move into trapezoids. Okay, so our formula for trapezoids is that our area is 1/2 of the height times base 1 plus base 2. All right. So I'm told in this problem that my height is 3. So I'm going to do 1/2 times 3. And my base 1 and base 2 are 9 and 12. So we're just plugging in the information that we are given. Remember, guys, order of operations, we need to multiply 1/2 times 3 to get 1.5. And then we need to we need to add 9 plus 12 to get 21. Then we could multiply together to get that we have 31.5. And our unit is centimeters, so it is centimeters squared. Please make sure that it is important all throughout this chapter, as we are dealing with a lot of area and perimeter, that you have your units on your answers. Okay? The next one that we're going to look at is the trapezoid. Okay? And what I want you to notice here is that we have base 1 and we have base 2, but I don't know my height. Okay? But what I do know is that this angle down here is a 45-degree angle. So what I'm going to do is I am going to draw in my height over here. And by doing that, notice what kind of triangle is created over here. I now have a 45, 45, 90. So those 45, 45, the 30, 60, 90, those formulas are not going away in this chapter. The trig is not going away in this chapter. We are continuing to use all of that to build on what we do next. So remember that our 45, 45, 90 triangle is an isosceles triangle. So if I find the length of this side, I know the length of this as well. So let's see, we were given that this is 8 up here, which means that this is also 8, because when we draw that perpendicular, we create a rectangle over here. Well, if this piece is 8, that means that this piece over here is going to be 14 minus 8, which is 6, which means that our height is also 6. Okay? Now, I could have given you just the 8 up here and given you 6 root 2 over here to get that the legs were 6. This piece you would know was 8, so then the whole thing you could add together. So there are a multitude of different ways that you might see a trapezoid given to you. And that does include using those 30, 60, 90, those 45, 45, 90 formulas. All right, so from here, I can now write my formula. 1/2 of the height times base 1 plus base 2. And again, remember, it doesn't matter which base you call 1 and which base you call 2. So we found that our height was 6, and our bases are 8 and 14. So 1/2 of 6 is 3. 8 plus 14 is 22. And when I multiply these together, I am going to get 66. And my unit is millimeters, so it is millimeters squared. Okay. We have one more trapezoid example here. And this one is one where we are working backwards. Okay, we're trying to find the second base when we're given the area. So again, we're just going to start with our area formula. So area is 1/2 times our height times base 1 plus base 2. All right, we're told that our area is 8 feet squared. We're given that our height is 2. And our bases are 3 and B2. We don't know what B2 is yet. Okay, 1/2 times 2 is just 1. So 8's going to equal 3 plus B2. We will subtract 3 from both sides and get that the length of our base 2 is 5. And our unit is feet. So 5 feet is the length of our second base. Okay, so if you have any questions on this, again, please write them down. All right. we are going to move into our next shape, which is a rhombus. Okay, so again, we're going to start by finding the area of the rhombuses. And remember that my area formula for a rhombus is 1/2 diagonal 1 times diagonal 2. So I know here in this picture that I have one diagonal is going to be 10 inches. But I don't know what the second diagonal is. So here is how we're going to take care of this. We are going to draw in the second diagonal. All right? Now, the first thing that we need to remember is that with our rhombuses, diagonals are perpendicular. Okay? Remember that they also bisect each other. So each of these pieces are 5. So now again, I have a right triangle where I know 2 of the 3 sides. So I'm going to start by finding this side here. I'm going to go ahead and just call it an X for our ease right now. So we are going to do x squared plus 5 squared is equal to 13 squared. So again, I am really just looking at this triangle. Come on. Trying to get the right color here that I want. This triangle right in here. Okay, so I'm using that triangle to do Pythagorean theorem. So now I'm going to have x squared plus 25 is equal to 169. I'm going to subtract 25 from both sides, and I'm going to get 144. To get x by itself, we're going to square root both sides, and the square root of 144 is an even 12. So that means that this length is 12, and this length is 12. So my second diagonal has a length of 24 inches. Now I can use my area formula. So area is 1/2 diagonal 1 times diagonal 2. So this is going to be 1/2 diagonal 1 we said was 10 inches. Diagonal 2 was 24. And when I multiply all these together, I'm going to get 120, and my unit is inches, so it is inches squared. All right, let's look at another one. Okay, I have a rhombus with 60-degree angles. So remember, if this is 60, then this angle over here is also 60. And all of my sides are congruent here. So those are all 6. And the diagonals bisect each other. So what I'm going to do real quick is sometimes it's easier to draw out one of these triangles just by themselves. So we're going to kind of tilt this so it's facing the same direction the other one is. So that way we have that. This side right here is 6 feet. Remember, my diagonals are perpendicular. That's going to be really big when we do all of these. And this is a 60-degree angle. So remember, this is my short side, my long side. So we're going to use our 30, 60, 90 formulas. So my hypotenuse is 2 times my short side. So my hypotenuse is 6. So it's going to be 2 times my short side. Okay, divide both sides by 2. I get that my short side is 3. So I know that this is going to be a length of 3. And this is going to be a length of 3 because those are my short sides. Then I also know that my long leg is my short times the square root of 3. Okay, my long leg I don't know yet. My short leg we just said was 3, so it's 3 times the square root of 3. So that means that this side over here is 3 times the square root of 3. And this side over here is 3 times the square root of 3. So my two diagonals are going to be 6, which is this one right here, so 3 plus 3. And the other diagonal is going to be 3 root 3 plus 3 root 3, which is 6 times the square root of 3. Okay, so again, we are still using those special right triangle formulas. They are not going away. They are not going to go away for the rest of the year, okay? So it's really important that you understand how to work these problems. All right, then from here, we can write our formula. Area is 1/2 diagonal 1 times diagonal 2. Okay, so it is 1/2. Diagonal 1 is 6. Diagonal 2 is 6 times the square root of 3. So when I multiply these together, 1/2 times 6 is 18. So it is 18 times the square root of 3. And my unit is feet, so it is feet squared. Whoops. Forgot to change back to the other shape. All right. If you have rhombus questions, please write them down now. All right. We're going to look at our last shape for today, which is kites, which is the same formula as the rhombus. Okay. It's still that 1/2 D1, D2. So what I want to do here in A is I want to find the length of the second diagonal when I'm given the length of one diagonal and the area. But again, we're going to start in the same place, which is writing our formula down. So my area is 1/2 D1, D2. We're told my area is 48 centimeters squared times 1/2 diagonal 1 is 16 times diagonal 2. So 1/2 times 16 is 8. So this is going to be 8 times diagonal 2. And when we divide both sides by 8, I am going to get that my second diagonal has a length of 6, and my unit is centimeters. So it is 6 centimeters. It is a length, not an area. So it is centimeters, not centimeters squared. All right. With this second one, again, I'm still using that 1/2 D1, D2 formula. But notice that I don't know any of the measures here in this second diagonal. I know that this is 9. Well, remember that kites are created by a multitude of congruent triangles. All right. This triangle here is congruent to this triangle here. So if this is 9, then this side over here is also 9. So I know that one diagonal will have a length of 18. But I need to figure out what the other diagonal is going to measure. Now, I'm not going to give you a problem you can't solve, right? What do we remember about the diagonals of a kite? Okay, this is where some more of this important information comes in. We need to remember that they are also perpendicular. So what do I create? When I look at them, I create this triangle here is a right triangle. And that this triangle over here is also a right triangle. So I'm going to use each of those triangles, the green to find x and the blue to find y. So the way that we're going to do that, once again, Pythagorean theorem. All right, so I know two sides of a right triangle. So I'm going to do x squared plus 9 squared is equal to 41 squared. I'm going to get x squared plus 81 is equal to 1,681. And we are going to subtract 81 from both sides, and I'm going to get 1,600. And when I take the square root of that, I'm going to get exactly 40. So 1,600 is a perfect square. So 9, 40, 41 is another one of our Pythagorean triples. Okay, we're going to do the same thing to find y. All right, I'm going to do y squared plus 9 squared is equal this time to 15 squared. Again, using the blue triangle for this one. So we're going to do 9 squared plus 81 is equal to 225. We're going to subtract 81 from both sides, and we're going to get 144. And since 144 is also a perfect square, my y is going to be 12. So I know that this is going to be a length of 40, and this is going to be a length of 12. So that means that this whole diagonal, when I add them together, is going to have a length of 52 feet. Now I can do my formula. My area is 1/2 diagonal 1 times diagonal 2. Okay, 1/2 diagonal 1 is 18, and diagonal 2 is 52. When I multiply all this together, I'm going to get 468. And again, this is area, and our unit is feet, so it is feet squared. Okay, I know that was kind of a lot. Hopefully most of this is something that is familiar to you. Again, the parallelograms, we're just extending the formula you already know for rectangles, so it's still that base times height. Triangles we've seen, 1/2 base times height. All right, the only maybe new ones was the, I don't know if trapezoid was new. Okay, if it is, it's been a while since you've seen it. And then the new one today for sure is definitely those kites and those rhombuses. So again, what we're going through today is just making sure that we understand how we can use those formulas to find missing information and to use our special right triangles and our Pythagorean theorem to help us find missing pieces to plug into our area formulas. Any questions at all, please write them down and I will happily answer them in class. I will see you guys later and have a wonderful day.